Awesome. So we're going to be focusing on what it means to build beautiful native applications with Xamarin, all in C#, kind of that end-to-end. And Donovan Brown earlier today talked about the DevOps side of things. And when they told me end-to-end, that could mean 1,000 different things. So Donovan talked about, like, what do you do after you write the code? Kind of putting into continuous integration, continuous deployment, monitoring your applications. I'm going to mention that a little bit. I'm not going to go too far in depth on that because that was a whole 60-minute session, and I only have 60 minutes or 75 minutes here. But I'm going to talk about the development part. So all of you out there that are looking to start building mobile applications, have already started building mobile applications, or you're just like, I'm just interested in what the heck Microsoft bought and who the heck this James Montemagno guy is. So we're going to take a look end-to-end. We're going to build some mobile applications out. I'm going to actually write some code. Hopefully it's not too scary. It's going to be great. We're going to tie up some stuff into Azure. That's going to be cool. I'm going to show you exactly how Xamarin works, why you want to use Xamarin, why I chose to build all my mobile applications in Xamarin starting in 2011, and why I've shipped now more than 70 applications to all the different app stores. It's because I love it. Okay, let's get into it. So that's me. I'm James Montemagno. I'm a principal program manager on the mobile developer tools team at Microsoft. Whew, that's a mouthful. I used to just work at Xamarin. I said, I work at Xamarin. So now they gave me this big fancy title, and I live here in this beautiful sunshiny city of Seattle, Washington. It is sunshiny, just like it is here right now in Chicago. I moved there in 2011, actually, to take a job. I was running printer software all day in Phoenix, another bright, sunshiny city, an actual bright, sunshiny city. I gave that all up to go work at a small startup up in Seattle. So I was like, printer software is fun, because who doesn't love writing printer software for 4 or 5 years? And I started to build mobile applications. And I moved to Seattle. I drink all their coffee, and I build all their mobile applications. Well, at least a few of them, I like to say. The coolest part of my job is that everything I get to do is open source on my GitHub. So all the libraries I create, all the apps I create, anything I'm blogging about is all on my GitHub page. And actually, the second, if not the first best part, is just interacting with all of you amazing developers. Coming up, if you have questions afterwards, a month from now, a year from now, I'm here for you no matter what. I like to talk a lot, even more so, not only just at conferences, but I also have a podcast. It's called Merge Conflict, which is an awesome name for an awesome podcast. So if you listen to podcasts right now, you can go into any of those app stores, search for Merge Conflict. Again, great title. It only took us 2 years to come up with. It's me and my friend Frank Kruger. We do it. It's on all sorts of different development, so not just mobile. So no matter what you're in, especially in the .NET space, I'm a Xamarin developer. He's an iOS developer using Xamarin, and that's what he does. Have you watched Channel 9 at all? Channel 9? Channel 9's like Microsoft's YouTube for developers. I have a show. It's called The Xamarin Show. Thought of that title myself. Very proud of it. You can go to xamarinshow.com. It'll redirect you right to the Xamarin Show page. Weekly development. So if you like audio, you like video, I got you covered. You guys can contact me anytime. Mots@Microsoft.com. That's my nickname. James Montemagno is a very, very long name. Snap that now. It's already in the slides that you'll have on your portal. That's my GitHub account and my Twitter name, James Montemagno. Literally just Google me, James Montemagno. You will find me. There's only one of me in the whole world besides my dad. Cool. Now, Microsoft, we really want to be your complete mobile solution and your complete DevOps solution, so everything that you need. I'm going to be focusing on the develop part, so building and crafting those great native apps for iOS, Android, and Windows inside of Visual Studio. But kind of the DevOps, you want to worry about testing your application and building and distributing and monitoring it. At the very end of it, I'm going to show you the tools that we have here at Microsoft that Donovan showed off earlier to really enable you to take the apps that we're building and get them through a full production pipeline, but also get feedback from your users as they're using your application, so crash reporting, analytics, and things like that. So when we talk about native applications, when I started in 2011, my very first day on the job at this small startup is my boss came into my office and he said, James, we need a native iOS, Android, and a Windows application for CES in 2 months, and he said, go. And I was like, all right, it's my first day on the job. I wrote one Windows Phone app one time, and Objective-C, Java, I don't know, I guess I could figure it out real quick in a weekend. Java will just lowercase a bunch of stuff and be good, and Objective-C, I'll just write stars and brackets and boot up Xcode, because I'm sure that's a great IDE. I'm sure it's better than Eclipse. Actually, anything's better than Eclipse. And it was interesting because he said native, native, native. He's like, we need these great native apps. And they were a hardware company. This was the first time they were ever going to build anything in mobile. In fact, I was the only developer using a Windows PC in Visual Studio. All of them were in Linux and Vim all day. Because they were PCB guys. They were just low-level hardware guys. So I needed something fancy, something flashy. So I was like, oh, man, if I'm going to write this in 2 months, that's not a lot of time. How am I going to do that? I need a framework. So I need something that's native. And I started looking all over the place. And I was like, man, how can something, be native if it's just running in a web browser? And I was like downloading POCing stuff. I didn't get it. So over the last few years, I said, okay, what does it mean to be native? And what do we want to deliver to our customers? And what do we want as developers? It's really easy. 3 simple things. First and foremost, great native user interfaces. There's a reason someone bought an iOS, an Android, or even a Windows device, is they like the look and feel of the hardware, but they also love the software. You need to craft applications for that device. There's nothing worse than me downloading an app from the App Store on my Android device, and it looks like an iPhone application. It's basically all the Microsoft apps that I install, and I'm like, oh, I don't even want to use this. Or heck, if they look like a Windows Phone app, you're like, oh, I don't want this. I want a beautiful native app using material design. I want it crafted to me. As developers, we want access to every single API that's possibly there, every single component that's out there. So if I want to integrate Apple Pay or in-app purchases or iBeacons or something unique that I need for my business, I should have access to it. Because both Apple, Google, and Microsoft, all 3 of them, they're adding really unique features to the platform. So I should have access to that. And of course, it has to be great native performance. You click a button, it just works. It can't be scrolling, it can't be lagging. It just has to be a great application. So how do we get there? How do we build these applications? Well, when I started, I thought I was going to have to do something like this. I thought I was going to have to go boot up Xcode, write some Objective-C and now Swift, and build an iOS app, then do some Java and Eclipse or Android Studio, and then I was going to be happy over in C# world, writing my Windows applications in Visual Studio. We call this kind of the silo approach, right? They're silos, they're app silos. Usually you have 3 teams working on 3 different applications, all trying to accomplish the same thing. It gets real, expensive really fast. Multiple PMs, multiple people managing. How do you sim ship features? How do you fix bugs? How do you do unit testing? How do you do UI testing? How do you set up your continuous integration and deployment for all of these? It gets really complicated because you have the smattering of all these different tools to try to accomplish the same thing, building a great application. So then you're like, well, what if I just wrote a bunch of code and then boom, apps? Like that's what my parents think I do. Like boom, write something and apps. Like boom, apps, code, jam, apps. Yeah. Every year I go home for Christmas. I try to explain to my parents what I do. And they're like, no, I think you just, and then someone gives you money. I was like, that is correct. Private and the student loans, just jam on a keyboard. Apps. Can you set up my Netflix account? Yes, I can do that. Here's my password. Beautiful. So usually think of this write once, run everywhere. You shove a bunch of code, usually HTML or JavaScript, into this box. And if you happen to be an HTML, JavaScript developer, that's great. I'm not. I don't ever want to do this. And kind of this app generator kind of plops out apps. Not always. There's about 1,000. It's like JavaScript frameworks. There's a dime a dozen. There's hundreds of them out there. Some better, some more native-y in a way, and some that are literally just a web browser that are out there. I won't name names. It's something like Cordova, for instance, something like that, or Accelerate, all these different ones. They all accomplish different things that are out there. And since things are usually running in a web browser, you're never going to get that true native performance. I always like to say you're kind of, at some point, developing against their API, not the API of the platform. So you kind of have this abstraction over common things in your JavaScript framework. And then if you want to get down and do the actual dirty work and get into those native APIs, you got to go write Objective-C, you got to go write Java, and then you got to go write the C#. And you're never actually crafting that great native user experience for each platform. And that's where Xamarin is completely different. When we think about cross-platform, we wanted those 3 boxes. We wanted great native UIs, 100% API access, and great native performance. We did 2 really important things. First and foremost, we said, hey, what if you just had access to every single API in iOS, Android, Mac, and Windows, all of them? Give you 100% API access, all in C#. That's number 1. Number 2, we said, what if we gave you access to .NET running natively on iOS, Android, Mac, and of course, Windows? And then you could share all of your .NET code, your C# business logic layer between all those applications, 50, 60, 70% of your app's logic. So things like models, view models, RESTful service calls, SQL databases, things that are the same across all the different platforms. It's just .NET code. Let me just write it and run it. That's what I want to do. And that's what we did. How it works is it's simple. We're in the Windows world forever. I've been writing, WinForms, WPF, Silverlight. Microsoft told me to write code in it, and I wrote it, and then boom, here's an app, and then a year later, here's a new platform, go write it again. Yeah, let's do that. Because it had this amazing thing called .NET, right? It's like a .do-it language. You dot, and then there's all this stuff I can do. I'm like, I want to do that. So it's like System Link, I/O, Windows, numeric, .NET, right? We go in, we have this awesome library, and forever it was just restricted to Windows platforms, which is cool because if I wanted to go and write a desktop application, a server app, a web app, or a mobile application for Windows, I just downloaded an SDK and I could add the platform-specific APIs on top of .NET. But that .NET that I knew and loved was always the same. So what we said is, let's just extend that over to iOS and Android. Let's give you all of that goodness with a beautiful .NET runtime that we create for iOS and Android called the Mono runtime. It's the original open source implementation of .NET, which is awesome. That can run super duper fast on iOS. You can share all that .NET code across the different platforms. Then we create these C# bindings around every single API in iOS and Android. So they're not just these thin wrappers. They're actually really powerful bindings to things like iBeacon and UIKit and Core Graphics, and this is only 5 of the 150 bajillion iOS APIs. So what those bindings do is we expose every single API in the same names and fashion. So if you were to look up like animate, it would be the same in both documentation, Apple and Xamarin documentation. But then we add C# features like async await, lambdas, events, delegates. So even though I'm accessing one of those native APIs, I'm doing it in C# that's familiar with awesome C# features. It's not just a thin wrapper, really powerful. Same thing on Android. You get all that .NET goodness on the bottom, all the Android namespaces up top, and then we also give you access to all the other things that are out there, like Google Play Services, the Android support libraries, everything that's available to a Java or Objective-C or Swift developer, all of it. You get access to all of it, 100%. I put it on the slide, all of it. We build out our user interfaces in one of two ways. What I fell in love with 5.5 years ago is our traditional approach, which I think is super duper important because you really learn how iOS, Android, and Mac and Windows works, is that we let you build out that shared C# logic business layer, and then you build out a native iOS, Android, and Windows user interface the same way that an Objective-C, Java, or C# developer would. For iOS, a storyboard file. You can use our built-in storyboard designer in Visual Studio, or you can use Xcodes if you want. And then you kind of build in and you layer in. So when they click a button, you then call into your shared code. So kind of you build a native UI with 100% of the UI widgets, everything that you want, all the custom controls, tie in the shared code. Android XML files. Android does everything in an XML-based markup. And of course, XAML in the Windows world. So this means that you're getting purely 100% native. You're getting like right to the metal of the platforms that are there with all the UI. But sometimes you're building like enterprise applications or maybe a conference application or something that doesn't need all those crazy animations and every single bit of the material design, all that wackiness and all that awesomeness that makes it really unique. You want just something that's like a login page. You want something that's a settings page. You're writing something like over the holiday I wrote a little scoreboard application. So when I'm doing board games, I can keep track of scores. So what we did is we said, we know that not every application needs this. We want our developers to be super productive. So we built something on top of the traditional approach. We call it Xamarin Forms. It gives you an abstraction of all the common UI elements on iOS, Android, and Windows. But you can still build in and share that C# backend business logic layer. So that means you can actually take your shared code percentage even higher, maybe up to 99% if you want to, if you don't need any of those native features, things like that. So really good for line of business applications. You can be super productive, pop out applications in days that are out there. And there's a few that I built. This Evolve conference application, you can download it from the App Store on all of them. I built that myself in about a month in my spare time, which is really cool. It's open source too, which is nice. Cool. Now, Xamarin is also a lot more than just applications. We also have our own game engines and work with other game engines too. So like MonoGame, UrhoSharp, CocoSharp, really popular libraries that we ship to build games that run anywhere from Linux, Windows, PlayStation, Xbox, it doesn't matter. Then a few other ones like Wave Engine, for instance. A bunch of other things we're building on top of our technology. So if you're looking to do applications, games, you're looking to do 3D modeling, UrhoSharp, for instance, is really, really powerful. So just know it's more than just applications. Again, that leads to great code sharing statistics. Anywhere on average, our developers share about 60 to 70% of code. That's our average. But again, all the way even higher. The darker color here is the shared code in two really popular applications. The first one, iCircuit, is by my good friend Frank Kruger. It's a circuit simulator, so he's an electrical engineer by trade. It's how he built his entire business with this app. You can see it's on all 4 platforms, and he's sharing anywhere on iOS to 70% of the shared code, all the way up to 90% on Windows. And that's just dependent on how much of those native APIs that you want. He's an iOS guy, so he really adds a lot of iOS features like iCloud integration and all this core data craziness that he loves, right? But on iOS, on Android and Mac and Windows, he can just bring over the core logic to still build his application. So it's really important to kind of know that's the amount of shared code you're looking at. And these are both traditional UI. So that light gray is the user interface and the actual, any of the native functionality built in there in C#. So I said, native user interfaces, native APIs, and of course, native performance. Everything that we do is all about native, native, native. That's why it's like on every single slide that you see here. When we compile up your application, on iOS, we do a full ahead-of-time compilation, that AOT, ahead-of-time compiled. So what we do is we take your C#, compile it down into IL, an intermediate language, one more time into LLVM bytecode, which gets sent through the LLVM compiler and optimizer, the same one that Apple uses to ship their apps to the App Store. So then, boom, you get a native ARM binary, all of your C# code, all your .NET code, that's all there. The .NET runtime's ahead of time compiled, all in there, and shipped up. You just ship that wherever you want, internally, external, App Store, boom, it's beautiful. On Android, we can leverage the craziness and awesomeness. That's why it's my favorite platform of Android. Every app kind of runs in a little VM. So we can run our .NET Mono runtime side by side the Dalvik Art runtime, which is Android's runtime. So we execute your .NET code over here and JNI across, like P invoking, if you will, the Java version of it to your Android applications. Now, to your users, whether they're internal, external, they go to an app store, they click install, that's it. It's like any other app that they've ever installed on their device. They have no idea that it was built with Xamarin, nor should they. Doesn't really matter. You probably have apps built with Xamarin on your phone. You have no idea. Why would you care, right? It just is a great app that's working great. There's nothing else to install at all. It's just an app, okay? And you're saying, James, well, ooh, you got to get this whole .NET thing. I've installed .NET, and what version of this executable and this redistributable do I have to worry about? You don't have to worry about that. It's not a big install or anything like that. What we do is we take .NET, right? And .NET, it's like this wall. It's like this. Let's imagine this is a tree. I'm going to jump down. Come on, camera guy, you got this? Imagine this is the tree of .NET, right? It's up here. But you're only using like SystemNet, HTTP, you're using like, IO, you're using a few other things, and you got 80% of .NET that's over there in the runtime that you're not used at all. So what we do is our advanced linker and compiler, we go and we just shake the tree, right? And anything you're not using falls off. We statically remove, we do analysis of your code. If you're not using it, it's not included in your application. So that means only 1, 2, 3 megs of this huge library called .NET get added into your application. And for me, adding 3 to 4 megs to my application to share 80% of my code, that's a good trade-off. So that's kind of how it works. We have amazing same-day support. We've been shipping same-day support for iOS since iOS 5, all the way up to the latest versions of iOS 10 and 10.1, 10.2. We have long developer previews, so when Objective-C or Java or all those other developers have access to dev previews, so do you, don't worry. Usually not same day for a dev preview, but a week or two after. But to me, it's really exciting because it's not just phones and tablets. What if you need something in your car? What if you need a watch application? What if you need a TV application? We have SDKs and tooling for all of them. So Apple Watch, Apple TV, the Fire devices, Android Wear, Google Glass that's still out there, all of them. You have access to all of them with Xamarin. So that's really important to know. It's any platform that you want to go to, so not just phones and tablets. Cool. 2 great IDEs. You can use Xamarin for Visual Studio, so it's an extension built right into Visual Studio. We also have Xamarin Studio, which is on the Mac. So we like to say you can develop wherever you want, whether you're on PC or whether you're on a beautiful rose gold MacBook like I have chosen out here for myself. I recommend everyone get a rose gold everything in their life. It's fantastic. Rose gold everything. That's my motto. That's why I didn't upgrade to the new Surface Book. Not rose gold. I don't want it. Oh, went ahead. Cool. So if you're in a distributed team, I'm on a Mac, you're on a PC, no worries. Same solution, same projects. It's all good. You go and download my source code, open it up, no matter what you're on, you're good. We also have Visual Studio for Mac coming out pretty soon. It's in preview currently today. It adds everything that Xamarin Studio has, so iOS, Android, Mac development, but it adds core .NET server loads and website flow, so ASP.NET Core and .NET Core and tools for Azure are all built into there. It's essentially the next evolution that we want to bring over to the Mac. So that's coming too. So what I always like to say before I get into code demos is just remember, if you take one thing away from today, is that truly anything that an Objective-C, Swift, or Java developer could do, you can do it in C# and Visual Studio. If someone asks me always the questions like, can I do this? Of course you can. Like literally, you can do anything. It's all free. It's included in your Visual Studio subscription if you already have one. If you're a community edition user of Visual Studio, it's included. Same with Xamarin Studio, it's in there. It's awesome. Yeah, Microsoft bought them, like, hey, make everything free. That's cool. Make everything open source. Yeah, that's great. Let's do that. So we did it. Everything is free. Everything's open source. There's no royalties, anything like that. You build an application, you ship it, you sell it. It's your day. Have fun. Let's build an app. All right. Whew, that's fun. Cool. All right, so here's what I want to do. I'm going to be building some applications first traditional. So I'm going to build out a native user interface. I'm going to talk to you about your setup. All of the development I'm going to do here is going to be done on my Surface Book right here instead of Visual Studio 2015. I'm not risky enough to install RCs, just 2017. I mean, now some of you may be risky, but maybe spin up a few VMs first. All right, cool. So this is my Surface Book. There's this beautiful desktop background I have here. And here's Visual Studio. Now, I have Xamarin for Visual Studio installed. If you didn't have it installed, you would just literally go to xamarin.com. And then there's this beautiful, this Antonio. This is James, Clancy. This is in an old office that no longer exists. We're in the new fancy Twitter building. I live in Seattle. I just work from my house. So you go down here and you just hit download. When you hit this, if you've already installed Visual Studio, it'll just install the extension. If you don't have Visual Studio, it'll install Visual Studio. If you're on a Mac, it installs everything you want and need, okay? It'll also install the Android SDKs, everything that you need to get started. If you guys have any problems at all downloading and installing Xamarin, let me know. We'll get you fixed, and then I'll report bugs, and I'll fix it, and I'll go hit somebody. So I say file, new. I won't physically hit them. I'll hit them with a bug report. That's actually worse. All right, so I do file, new project, and I do a lot of zooming, so no matter where you're sitting, you're good. So I go in here and I hit new Android application. I have all my Android applications, an Android Wear application, an OpenGL, a single view app. I have iOS applications, like I have Apple Watch apps. I have extensions, so all the audio extensions, broadcast extensions, sharing extensions, all those fancy widgets that are all over your iPhone. iPad, iPhone apps. I have tvOS applications. There's tvOS, that's here. And Xamarin Forms is hidden under cross-platform up here, so that's where it'll be. Now, if you're an F#, any F# developers? There's usually sometimes one. If you want to get crazy and you're like, hey, can I do all that in F#? Sure, just go down to F#, and there's Android, there's iOS. I always try to learn F#, and then I just get confused and I run away. It's awesome. So here's what I did is I want to build an application. I drink a lot of coffee. This is number 3 today. I actually had to go to a coffee shop to get like portable coffee for later. I want to build a little application that I can kind of just show you some cool native functionality, build something out really quick. And what I want to do is build a little application. It's kind of like map focused. So I can maybe like do a Google search to find like coffee or tea or something like that, and it would pinpoint all of them on a map. So what I've done is I just went in and actually created a cross-platform app, and it's just an iOS and Android application. So what I'm going to do is I'm going to show you this setup. It's called HockeyApp. And I have links to the GitHub, and it's all in the PowerPoints and all this stuff. It's already open source. So when you create a new application, it'll give you an Android app, an iOS application, and either a portable class library or a shared code project. That's what it is here. I just have a shared project. There's multiple ways of sharing code. Portable class libraries are good. .NET Standard libraries are good. Shared projects are also good. I like to use these because it's the easiest way to share some code. But essentially, all of my business logic, so models, view models, helpers, things like that, all go in here, just my .NET code. And I'm going to actually start there. I'm going to write some code. So Google has an API, a Places API, where I can search for something, and it will give me some results. So it just returns a bunch of JSON. So up here, I have some JSON results, like a list of places. If I go into this places thing, I can see I have like an address, address formatted, phone number, ID, and name, any of this stuff in here. They give me a nice RESTful API. So I have all my models in here. So all this stuff that I'm going to do first is in my shared code. And then I have this thing called a coffees view model. I like to write things in like an MVVM type of way. So the first thing that you're going to notice is I have some system namespaces, so threading, collections. I have JSON.NET installed, just a NuGet package. And I have a few other things in here. Now, iOS and Android don't traditionally have a data binding system in place, but I'm just a big believer of MVVM. When I fell in love with Silverlight and WPF, I just fell in love with data binding. So I kind of architected in this way. We can see here that there's this Google long URL that is in here. It takes like a query, it takes a location, so latitude and longitude, and a radius in here, and an API key. So the idea is you hit this RESTful endpoint, it's going to give me some JSON, and then I want to just display that in my mobile apps. So here what I do is I have a thing called coffee, because the JSON results are really big and really tedious. So I have this thing called coffee, and I have an observable collection here. So what I want to do is just give it an ID, a name, and a latitude and longitude that I can display, and I'll talk about this Azure thing later. So inside of here, first thing I do is I create this little isBusy. So I like to say, like, if someone jams on a button, they can only jam on the button once, and I'm not going to search again. I created a little method here called search for places. And here's what I do is I just do a string format. So they pass me the latitude, the longitude, and the query. And then I go and I get this endpoint here. So now what I can do is I can come in and I can say, let me get some JSON, or let me get a client. So I'll come in, I'll say new HTTP client. I can say var JSON equals await client.get string async. Pass it the request URI. Now I have some JSON. Now what I can do is I can get some results, and I'll say JSON convert dot deserialize object, and that should be a query, search query result, and I'll pass it the JSON. So the search query result, if I peek into that definition, that's the one that I just showed you, so it's page. I'm just going to grab the first page. It'll give me a list of places here. So I can do something like if results equals null, let's just return. Else what I need to do is convert those Google results to my own list of coffee. I just made it coffee because that's all I ever search for in my own apps anyways. So let's go ahead and grab and convert those. So I'll just say get coffees, and I'll say results. And of course I'll zoom in because I like to zoom just a little bit better here. And there's my places, and I will say select. So let's use some link here, and let's get the C, and I'll say new coffee. There we go. Now I can just fill it in. The latitude, I'll just say that is my C.latitude. Longitude equals C.longitude. And then the name is just going to be C.name. Cool. So I just convert those into my own data objects that I want to display. And now what I can do is I can say I have this places, so that observable collection. It's like a list. I'll say replace range. So it's going to delete everything in the list and add a new IEnumerable, add my coffees, and oops, coffees. There we go. Done. So I like to start here because it's literally just a C#.NET code. You've probably written HTTP clients a billion times, and everyone's used JSON.NET. Let's see, NuGet.org, packages, 43 million times. We've all used JSON.NET, right? So we're there. So I like to start there, and then I say, all right, let's build an Android application. Let's just take this, let's go in, build a little bit of user interface, and set this all up. And we can see what I'm doing down here is I just at least console write something here. Cool. Now already we're sharing our models, we're sharing this logic. Now I can come into my Android application. Let me talk about this structure here. So as I zoom in over here, we can see that I have an Android app. The first thing that we're going to notice is if I was to right-click and say Manage NuGet Packages, I could go to my installed, and I see I have a few things. I have some Azure stuff that I'll get to, HTTP client, JSON.NET. I have a SQL database installed. Down here I have all these Android support libraries. I have Google Play Services, so I have access to my maps. So I have all these libraries that I brought in. We love NuGet. If I drop down the references, we have all those references I just add. And that little double diamond is all my shared code. So I'm importing all of that shared code into this project right away. Down here is mono.android, which is all my Android namespaces. So every single Android namespace is all available to me. So then I can get a little bit further. So I have these things called resources. So we structure our Android and iOS applications the same way that a Java or Objective-C application developer would. In fact, you could drag and drop files from a Java or Objective-C app into here, like the design files, because we use the same formats. So we have drawables like my app icon. I have these layouts, which is going to be the main view of my application, and some values, so like string translations, colors. So I'm just going to double tap on this main AXML, which is Android XML. The only difference between a Java app and a Xamarin app is we append A to the XML instead of just XML, so we know how to open it. Literally just remove the A, and then back and forth. It's the same file. What this will do is it'll open up our our Android designer for Visual Studio. And the first time we take it, it's going to load up a bunch of stuff. We can see over here already I have a bunch of items in my toolbox, so every single Android widget. I'm at an extremely weird resolution and things like that, so all the icons look a little bit not great. But here so far I have just my Android application. And all I've done so far is I've just added this fragment, which is my map. So we have a designer, it's drag and drop, and what it's actually generating here and looking for is the actual Android XML. So this is the Android XML. I have a linear layout, I have this fragment, which is my map that's down here, and it's the same thing. So what's nicer is if you look at Android documentation or snippets, put it right in here. So here's what I can do is I can come into this designer now, and we want to do something. We want to be able to get some text. So I'm going to go ahead and get some plain text entry, and I'm just going to drag it into this first linear layout. I'm going to go ahead and add a button in here, so it's just a button. Add it there. I also want a little progress bar on the bottom. So let's go ahead and put that down there. That looks good. And we can go ahead and fix this up now. So I can drag out my properties. Here's every single Android property that's here. So they're all grouped together that's in here. I like to just do alphabetical so I can see it. So here we have every single property. So it's called button 1, which is a great name for a button. I'll just say that the text on here is search. And as we update it there, it updates there. And we can notice that if I actually tap there, that it says it's edit text 1, but it's really small. So what I want to do is first set the hint in here. So we'll give it some background information. And I'll say enter something. There you go. So it's a little bit bigger now. But we really want it to fill the whole area. So what I can do is I can go into my width, and it says wrap content. So I'll just set it actually to 0 first, and 0, and that's no good. But I want to set the weight here to 1, and then boom, it just fills the remaining space. So that's going to be my user interface. I enter something, I hit search, I want to update the progress bar. So drag and drop, pretty easy. Now this view here has some code behind, so there's this main activity that's behind it. Every single page of an Android application is either an activity or a fragment. A fragment's a little section inside of an activity. But an activity is the house of your application. And it has the lifecycle events like on start, on pause, on resume. So we can see a few things. I have this activity. It's a main activity. I have this on-map callback interface, so when the map is ready to display. And then I go out and I just have access to things like the edit text, the button that I'm going to get, and the progress bar. So these are members that I can expose that I have access to. Up top, we can say I have access to, if I do using, and I can do system dot, and I have all the system dot. If I do Android dot, I have all the Android namespaces available. So now what I can do is I can come in here and I can say, OK, well, I need to set up my main UI. And I'm going to say search button equals find view by ID. And we can see that I'm going to tell it to use that main layout. It's going to inflate the XML. Then I need to personally go search for the items that I want to interact with. So the search button is going to be a button. And it's going to be resource.id.button1. And it automatically finds that for me automatically. Now I can say query, which is going to be my edit text. I'll say find view by ID. It's edit text. And I'll say resource.id.editText1. Again, great names for these things. Progress equals find view by ID. It's going to be a progress bar. And resource.id.progressBar1. Cool. Now, what I've done down here is I want to set up a few things. So I have access to my code. I also want to create my view model. So I want to access that view model. So I'll say view model equals new copies view model. So I'm going to start accessing that shared code. Okay. Now, what I want to do here is I want to say, hey, every time the property change that is busy, I want you to call a method. And that's going to be my view model property change, which I've set up ahead of time. Additionally, what would be really great is that every single time you update the places, view model, come on, IntelliSense, view model, dot places, dot collection changed. What if I just get a little subscription here to whenever I update that collection too? So places changed. So whenever I update a property or whenever I update that collection, we're going to go ahead and do some stuff. So the first thing is down here is I just check the is busy, right? So I enable or disable and show that progress bar that's there. I should also make sure that the progress bar is indeterminate. Is indeterminate equals true. Just make sure it is always going. And then what I do here is I have this places. So whenever I get new places, I want to put them in the map. So I wrote some of this code ahead of time. It's very simple logic, right? So I have access to this Google map. And what I do is I loop through all my places. And first I clear it. And then I go set up markers on it. That's all I do there, little markers. So now whenever I change the collection, it's going to go and clear my map, update the map. Whenever I go ahead and change that isBusy property, whenever I go and search, it's going to enable or disable the user interface. And now I just need to call that method and actually send in what I need. So I set up my map, and I should go down here and show you the little map ready code. So basically what I do is whenever the map is ready, I just get access and I set up my map. So again, some native code. I'm going in, and this whole app right here is going to be like 150 lines of code for an Android. So here I go in, and now I can just say search button, dot, and I have every single Android property, but I want the click. I'm going to say async sender args. I'm just going to do a little lambda here. There we go. And now what I can do is I can just say, hey, I want to grab my text, and I'll say query.text.trim, for instance. And then I can say await, and I'll say viewModel dot. Or let me grab the center of the map, actually. I'll say var center, and I'll say map dot camera position dot target. There we go. So that's the center. It's where it's positioned at right now. And I'll go ahead and say search for places. And I just need to pass in the lat long in the query. So I'll say center dot latitude, center dot longitude, and text. Boom. Now realize that whenever I call this and I go in here and I say go to definition, I can now set breakpoints in here. So I can set this, I can set my results, I can see what's coming in. And this is going to update that isBusy. So in my shared code, I'm triggering these changes, and my Android view just subscribes, essentially, that's in here. Now again, there's no built-in data binding, so I'm kind of manually doing this. And I like to show this first because there are frameworks that do this for you, which removes all this code. Things like MVVM Lite and MVVM Cross, which are cool. So there we go. It's very simple, right? I add a click handler. So now what I can do is I can just build up this application, have the user interface, I can build it up, and then I can deploy it on a simulator, I can put it on a device, I can put it on anything I want. I boot it up. I just have an Android emulator here. It has Google Maps and things like that installed on it. We have Hyper-V enabled ones. These are like Intel virtualization ones. Any Android emulator, any Android device actually would work too. You just plug in your device and it would go ahead and output it. So when I hit debug or build on here, it's going to go and compile all my code, my entire application, right here on my PC. So I always like to make sure that it's actually doing stuff and this whole thing is going. And what we can notice up top is that the debug menu is finished compiling, has actually a list of all of my emulators that I have installed. We have some toolboxes over here to help you manage your emulators, your SDKs. We kind of build some tooling inside of here. So now what I can do is I can just say, hey, debug, and it's going to now package up that application and ship it onto the emulator, and I can just start debugging a fully native Android application right on my PC from Visual Studio. There we go, starting to debug. Launches, there's my HockeyApp. It looks like my designer. It's going to go do a bunch of stuff. And you can see it's indeterminate, so it's actually still running. I forgot to disable it, so that's no good. We can do that later. So here's what's cool, though, is I can come in, and I zoom in automatically to where we're at, somewhere over here. And I'm somewhere, where are we at? Are we in? Yeah. We're like down there. There's no coffee. Wait, where am I at? Oh, there it is, Chicago. I'm like, what? I'm like, Oakland. Where am I? So I know I was definitely over here earlier, so I'll say coffee, and I'll say search. Now notice that it kind of freezes up for a second because I hit a breakpoint. So I can actually go back here, and I have a breakpoint. I have my result. Here's this query. Here's the latitude, and here's the longitude I passed in. I'm going to say continue. It's going to go off. My UI is responsive, right? So it's actually doing this stuff. I come and get that JSON. Here's this huge JSON blob. Boom, here it is that Google returned to me. Now you're probably saying, like, James, how did you get all that fancy stuff? Well, I went to JSON to C#.com. I pasted my JSON in there, and then I got all these classes. We've all done that, right? And if you haven't seen that, you're like, whoa, that's the coolest thing ever that I've ever seen. Pretty sweet. It's actually super fun. Everyone loves that. Paste some JSON, you get some C#, and that's how I did it. So we have all this stuff, and now I'm just going to go ahead and step through, and we'll go ahead and get our coffees back. So we'll remove this thing because we have some results, and we got some coffees. And let's go ahead and step one more time over this. We have our list, 20 coffees that are coming in here. We have our Starbucks and probably there's a Pete's, a Metal Coffee, all this stuff. So I'm going to continue, and then there's all of our pins on our map. Super responsive, really cool. I can click on one of them. I automatically get these little pop-ups on top of it. I was over this one. That's where this is from. Very, very good. I recommend it. So cool. So I can go in here, but I can search for anything, right? So I can come in, and maybe I want some vegan food. I'm sure maybe there's some vegan food. Maybe pizza. I'm in Chicago. I don't know. There we go. There's like, one really, really good deep dish pizza place, and then one that's also everyone goes to when they're tourists. I don't know. Giordano's, is that one? I don't know which one's good. Which one? Uno? There's a lot of them. So there we go. So it's instant, right? We're snappy. We're using Google Maps. We're doing all this stuff. And granted, it's not the most beautiful UI. I just built it in 5 seconds. Cut me a break. Cool. So let's go ahead and reuse all this code on iOS. So what I can do here is I can start building out my iOS application. So if I go in over here, we can say I have an iOS app. I have references to all the same NuGet packages, my shared code that's going in here. And then I have resources like my launch screen that will be displayed. And I have this thing called this main storyboard file. Now there's a few things. I can browse all my code. I can compile my code from a PC. The problem is when I want to actually do some design work or I want to put it on a simulator or device. Apple, you got to have a Mac. You just got to have one. It's in their EULA. We can't break it, so you can't break it. So what we do here is we essentially set it up so we give you all the tools in Visual Studio to design, build, and do a full deployment with just having a Mac sitting somewhere on the network. I'm just on the demo Wi-Fi here, nothing special. We make a secure SSH connection from your Mac, from your PC to your Mac. Right here, you can see there's my IP address on my Mott's book. And this is just connecting right here. I've installed Xamarin and Xcode over here because all of Apple's tooling lives on a Mac. Right? It just does. They don't ship it on a PC like Google does. So we built all the tooling. We installed Xamarin, installed Xcode. That'll connect, and it'll automatically build up and do everything over here from Visual Studio. So when I tap over here, I'm connected. It's green. I tap on that main storyboard. It's making this connection out to my PC, and I'll go ahead and remove some of these things. And it's spinning up our actual iOS storyboard designer inside of Visual Studio. And it's just like the Android one that's there. Except for now, we're going to design our iOS application. So again, this is going to be the first time spinning it up, so it's going to take a few more seconds here over this beautiful demo Wi-Fi. Now, this Mac, I should say, is a beautiful rose gold Mac. It doesn't have to be a beautiful rose gold Mac. It could be a Mac Mini, a Mac in Cloud, Mac Stadium. These are like cloud-hosted solutions. But again, it just needs to be a Mac somewhere on your network or an IP address. So hosted solutions like Mac in Cloud and Mac Stadium, which are not Microsoft things, they're third-party companies, they let you rent a Mac in the cloud. So over here, we have the storyboard designer. I'll zoom out. I actually built this UI ahead of time because I only have so much time. But you can see it looks pretty similar. I added a few more buttons in here. But I have this map that's over here. I have all the toolbox items. Storyboard designers are like a full application or partial parts of the application. So each one of these is a view controller. So here's a view controller that's here, and I can just interact. I can drag and drop items around. If I bring out my properties, what we do is we have all the properties just like you would expect down over here. So I have this little text field. I have a button that's over here. I have a map view that's down here. I have this little progress icon over here. And we have full support for essentially anything that you can do inside of Xcode. In fact, you can open this inside of Xcode. So we have these auto layouts, constraints, everything that those systems are. What you can also see over in the properties windows, we name the items. So button search, text field query. I have a save button. I have my map down here. You name the items. You have access to all the events, anything that's inside of it to do some code behind. There's no events on a map. So what I can do here is this view controller. If I scroll down, I tap on it, we can see it has a class associated with it, view controller. I'm very creative with my names. So that storyboard has this code associated with it in the code behind. And iOS has a beautiful, elegant API for all their stuff, so it's actually a lot less code. But what we're going to see down here is I do a few things. I have this view controller, has some lifecycle events like view did load, view will appear, things like that. I rigged up everything ahead of time. So I just did some little properties here. So when our property changes, when our collection changes in our view model. I also have some button click handlers here. And you can see I'm going to zoom right here over to Chicago. So what's cool here is when I tap on that button search, I'm just going to go ahead and call that one line of code, right? So it's like a single line of code that I'm calling from my iOS application to go do the query. Whenever my collection changes, I just simply go off. I remove any of these annotations, those little dots. And then I use link to just add a bunch of annotations here. So I convert it from my coffee place to the iOS-specific API. Same thing down here. Whenever the property changes, I either show or disable the buttons in my user interface. So very simple code, very simple logic. So what's nice here, since this code's already set up, I can go and I can just go ahead and I'm going to do a clean. I like to do a clean and recompile as I jump around about 100 networks. So I'll go ahead and clean first. I'm going to go ahead and rebuild. And what's happening here is that it's going to compile my C# locally first. Just make sure it compiled, make sure I didn't have any typos. And what we're actually going to see is that we're going to see there's an error. And if you see this error, you're going to be like, whoa, what is this? What does this mean? No install provisioning profiles match the installed iOS signing identities. What does that even mean? That's a terrible error message. And what that's telling you is that you wanted to put it on an iPhone instead of an iPhone simulator. So you tap iPhone simulator. Then you get all your iPhone simulators here. To put it on a physical device, you need this thing called a provisioning profile. It's like a handshake between Apple and you. It's terrible. You'll learn to hate it as much as everyone does. Everyone has to go through it, so not just that. So now when I rebuild, it'll recompile the application fine. So we give that little error message. That's there. You don't need it for a simulator because it's just a simulator build. And a provisioning profile is a way so essentially people just don't redistribute apps willy-nilly. So it limits you to installing it on select devices for development. So now I can just hit debug. So we can see it listed all of them here, all these devices. There's a lot of them. I'm just going to put it on this iPhone 5S. Now, one of two things will happen. How many of you have Visual Studio Enterprise? So for all you lucky folks, that's what I have. So you'll see the same thing. Pro or not Pro? Or Community? Any of them? So Pro and Community, when I hit debug, it's going to actually launch the iPhone simulator over here onto your Mac, because that's where it lives. Right? So Community and Pro users. If you're an enterprise user, you get to take advantage of a really awesome enterprise feature, something that we just developed and just launched in the last 6 months. It's called the Remote iOS Simulator for Windows. It gives you the full power of an iOS simulator, but on your PC. It's connecting to your Mac and doing a lot of magical bits that Scott Hanselman ruined by telling everyone by opening up Process Explorer. But it's here, and I have this full map. What's really cool is that we actually improve it. So I have a touchscreen surface, so I can just pinch to zoom. I can move around with my finger, right? And you can see it's based on Wi-Fi, and things are happening. Things are communicating here. But as I go in, I can now hit the search button here. It's going to go off. It's still responsive. I'm seeing the user interface update as it zooms around. I get all the pins that are coming in. I can tap on a pin with my finger. It comes up. I can go over here. I have the same application, the same exact code that's running either way. I can, of course, do screenshot, touch ID. I can enter things with my keyboard. So if I go in here and I say salad, I can't find any salad, rest assured, in Chicago. It's somewhere. There's like one restaurant that has salad, I swear. There we go. So there's, mixed screens. That sounds good. I'm a big salad person. Salad and coffee. I could just die on that. So there we go. So it's going to go off, do all these searches, and you have all access to everything here. Boom, but on a PC. Really cool. But again, I'm sharing all that logic. So maybe a little bit of logic here for iOS, a little bit of logic for Android, but sharing that vast amount of code. That's any of that. So now if I go and change any of my business logic, it will automatically update on iOS and Android anything that I want. So if I change, I don't want to go to Google. I want to go to Bing, or I want to go to something else. I want to hit my own database. I can do that. Cool. All right. Let me talk a little bit about how we simplify development. So you saw that I access a lot of native APIs, a lot of the native map APIs. That was a lot of the logic. So what we did is we said, listen, we're building that shared C# backend, but what about all those other things that are up in this area? We know that it's the user interface, because I've been interacting with the user interface. What are things like GPS, battery, text-to-speech, notifications, connectivity? Right? What if I want to check those things? Well, each of these have their own API for each platform. So what we said is, what if you didn't have to write and learn all those different APIs for iOS, Android, and Windows? And what if you could just access it all from shared code? Right? So what if I want to do text-to-speech? I just hit a cross-platform API that says speak. And I say, hello world, or I say, I'm about to go to Starbucks. and it just uses the native implementations on each platform for me. Wouldn't that be wonderful? Well, we did it, and they're called plugins for Xamarin. It's one of my big initiatives, so things like taking photos, push notifications. I just wrote a new one called in-app purchases to do in-app purchases from shared code, 3 lines of code to do in-app purchases. So let me show you what this means. It's lovely. This is my favorite part. So here's what I want to do is, let's say right now this application, if I come into my shared code, 1,000 things could happen wrong right here. I could be offline. I could have spotty network. Maybe I want to cache something in a database. Maybe something goes wrong, so I want to pop up a dialog box. So here's what I can do is I can come over to xamarin.com/plugins. And this will tell me all about plugins. Again, James and Antonio. And we can see it's going to be a cross-platform API for iOS, Android, geolocation, settings, permissions, connectivity, file system, notifications. And I can just go down and say Browse Plugins for Xamarin. And plugins for Xamarin are all open source. They're built by the community, some by Xamarin and Microsoft employees, but a lot by the community. So you can see we have these things like the Google Play Services, the Facebook, and a cross-platform auth account. But then we have other things, battery status, Bluetooth LE, calendar, compass, connectivity. We're going to want that, so let's open up the GitHub. External maps, file picker, geolocation. There's that in-app billing, local notifications, and then we have things like sockets and speech recognition. And here's the user dialogues, so I can open those. So here's like the user dialogues. I can browse all the source code. Everything's open source under MIT. So I get things like date pickers, loading, progress, login, toast, time, alerts, confirmations, all from cross-platform. Connectivity. Here's my connectivity plugin. I'm going to show you guys this. Again, we trust this guy because he seems trustworthy. And when I open that up, cute. That's how I look at all my source codes on GitHub. Is that a cute developer? I'm in. Is it not cute? I'm still in. Let's do this. Going to download your NuGet. So, all right, plugin, right? Check this out. So you can see here, everything's really well documented. I really worked really hard with the community to standardize on this. You can see right in here, I don't support Xamarin Mac yet, but I do support all the way back to Windows Phone Silverlight 8, Phone 8, UWP, iOS, Android, it's all in here. Here's the API. Is connected. Give me the connection types, bandwidths. I can ping and see if something is remote reachable that's in here. I can register for connectivity changes. That's really cool. Here's an example of using Xamarin Forms, like just register for an event and then display an alert. And it'll add the permissions for me automatically. Really cool. So check this out. I'm going to go in and we say Manage NuGet Packages. I've installed these ahead of time. So if I go in here, I have the User Dialogues plugin installed in iOS and Android, or any of your shared code. Down here, the Connectivity plugin. So right here, those plugins. So again, in my shared code, I can come up to the top, and I'm going to say using plugin dot connectivity. I'll say using acr.userDialogues, because that's the API there. So let's do this. We'll say if not cross connectivity dot current dot is connected, one line of code, check for connectivity, right? And what that call does on each platform is it reaches into the native stacks. So here's Android. On Android, I wrote all of this code to check connectivity on all the different platforms for you. I wrote all of this code that keeps going. And I did that 7 different times on every single platform because I never wanted to write it again. I have a good friend, Luke Carries, who told me, he's a web developer though, so we'll cut him a break. But he goes, if I ever have to write a piece of code twice, I package it up and I put it on NPM. For me, if I have to write a piece of code twice, I package it up and I shove it on NuGet. And that's where plugins were born from. So now what I can do is I can say, hey, well, you're offline, so we don't want to do anything. We don't even want to set is busy is true. We'll say await, and I'll say user dialogues dot instance, because I know the API here, and I'll say alert async. And I'll say the message, you are offline, frowny face. And I'll say, hey, don't do that. Don't give that message to your user. But there's all these different things. So you can do progress. You can do all this stuff inside of there. And boom, just in 2 lines of code, I've checked connectivity. So let's check this out. I'm going to go in, and I'm going to go ahead and set Android as my startup. I'm going to go ahead and deploy again. I'm going to set a breakpoint right here. It's going to redeploy my application. So again, all I did was install NuGet packages. That's it. And now I can go in here, and we can do like coffee and close that down. We'll say search. So again, it's going to go find the coffee places because I'm still online. There's one overflow. I can come in, I can put it in airplane mode. So now I'm in airplane mode, I'm offline. Boom, I'm offline. Connectivity is connected, false, right? Now when I do user dialogues, boom, you're offline. Native functionality from my shared code. I do all sorts of stuff. I take video, I take pictures, I can do barcode scanning, I do calendar integration. It's amazing, this whole world. If I do this on iOS, if I do it on, it doesn't matter. It's all purely native, it's beautiful, it's awesome. So when you think about, oh, I gotta write all these interfaces, I gotta write all this native code, you don't have to do it. Right, it's all here. If a plugin doesn't do exactly what you want, they're all open source. Under MIT, go take the source code, put it in your own app. It's beautiful, it's wonderful, I love it. Cool. It's pretty cool. No? Yes? 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 Awesome, yes. So Alan Ritchie, who created the user dialogues, I'm trying to get him to switch the namespaces. So here's what I do is, all of mine are plugin dot, and I have templates and things to build your own. So when you go to NuGet, all you got to do is just this. Just search James Montemagno, and then you find all of my libraries, and here they all are. And I have things like permission settings. All of mine have the standard plugin dot. Most of the community members do. The problem was that I decided to make the breaking change to update all my namespaces, and Alan wasn't quite. When you have like hundreds of thousands of people using your library, you're a little bit skeptical of changing namespaces. So, but I did. I was like, psh, broken app. It's fine. Deal with it. Deal with it. Anyways, it's really cool. So I love this stuff. I mean, they're all there. I contribute to a lot of things, as you can see. This one's my favorite. Oh my goodness. Check this out. So in-app billing. This is how you do an in-app purchase. You connect to the billing API. You purchase something asynchronously, and you disconnect. Boom. You're done. That's crazy. That's crazy. I wrote that in like in a few days. It's pretty cool. On Android, let's go into this puppy. You just keep going. Just keep going. Like, who would ever want to write this code ever again? I think 3 lines of code is much nicer than 653. That's the type of, when I'm talking about shared code, right, those 60–70% of code is just the code that you're writing. That's not including all the plugins. By me installing those plugins, I've just saved myself thousands of lines of code that I don't have to write anymore. It's awesome. All right, let's go a little bit further here. I'm running out of time. I got 15 minutes. 15? 18 minutes. My thing's not working, so I'm assuming 18 minutes. Here's my next favorite part. You got to sometimes integrate with a backend server. For our Xamarin Evolve conference application, I had thousands of attendees downloading and using it, push notifications, and we're doing online, offline data synchronization with all of our speakers, all of our sessions. What's really cool is that I was able to build a full ASP.NET backend for my application that shared a lot of my actual models with my mobile application. So I actually had a code sharing story between my actual server application and my mobile applications. Now, when we think about going for a backend, we obviously want something that can really scale out. And of course, we're at a Microsoft conference, so you know I'm going to talk about Azure. I loved Azure and our services that we have in Azure for mobile apps before I joined Microsoft, when I was at Xamarin, even before Xamarin. What's really cool is it's everywhere. Everywhere you're possibly at that you want. We have 36 plus regions all over the world, more than AWS and Google combined. I'm sure you've seen this slide 1,000 times. But no matter if you're in Canada, China, India, no matter where you're at, you have something available. Now, there's something that lives inside of Azure. It's called Azure Mobile Apps. It's inside of App Service. So the same place where websites and things like that exist. Azure Mobile Apps is your full backend for your mobile applications. They're super powerful. They give you 2 ways to develop. They're flexible, a Node.js backend or a full ASP.NET backend that you can just add on top of your existing ASP.NET application today. It's just a NuGet package. It's a mobile SDK that you install. And what that does, it builds your essentially RESTful API and handles talking to your mobile optimized database. So it could be a Mongo database, a SQL Azure database. It doesn't matter. And then what it does, it gives you a beautiful client SDK that's cross-platform for all of your C# API, or C# applications built with Xamarin. And if for some reason you have to still write or support an older iOS, Android, or Cordova app, well, they'll work there too. So it's a backend for any of your mobile apps. And it works like this. You have a client app where you install an SDK, and that essentially is your bridge between the RESTful API and the Azure mobile app backend. And that's where all your services live. Things like data connections to SQL Azure, tables, Mongo, Office 365, API, Logic apps, anything that you want. It also handles user notifications and push notifications. So instead of calling direct REST APIs, which you might normally do for your actual controllers, what it does is it gives you a nice insert, update, delete, CRUD operations on a table, and it handles talking to the backend for you. And the beautiful part is it does online, offline data synchronization automatically. You don't have to do any of it. It just handles it for you automatically. Then you have your backend code. That could live anywhere. It could live in Azure. It could live on-prem. It could live anywhere. It doesn't matter. Now, not only does it do table storage, but it also handles push notifications, so iOS, Android, and Windows. And it also does blob storage, online, offline data sync too. So if you need to do image uploading, file document uploading, it'll handle that all for you automatically cross-platform. So here's what I'm going to do is I'm going to actually add an Azure backend to this application in about 5-6 minutes. So what I've done here is I go to this beautiful portal, and I do file, not file new. It should be file new. That'd be great. Hit plus button. And we all just really wanted to say file. New. And under web and mobile, you're going to find web apps, mobile apps, logic apps. When you spin up a mobile application, you're not actually creating an iOS and Android app. You're creating a mobile app backend for your application. So you set this all up. You pick your name, wherever it's going to live on your Azure websites, your app service plan, all this stuff. Essentially, where does your ASP.NET website live? So I've already done that, and it's called Tech Summit Coffee. Boom. And it spins it up like this, and it's essentially just an app service. So here it has a URL, so when I open that up, I'm going to close all these other dialogues. We'll let our Azure website, I think I'm on the free tier, so it's probably asleep right now, so we'll let it spin up. I'm on this default service plan, I have FTP, all that stuff, and you have all the access if you've done anything in here, so like continuous delivery, continuous deployment. You can scale up, you can scale out, so if you want to scale up, scale out, whatever you want. So I can bump this and I say, hey, what is this going to cost Microsoft right now to put this on a S2 instance? Cool. All of a sudden now I have a VM that has 2 cores and like 4 gigs of RAM. Like that's how I scale up my application. And then down here, we have data connections. So I'm actually connected to a SQL database ahead of time. If you don't have one, you can just hit add, and you can set up a new SQL database or storage in here, like DocumentDB or pointer to Mongo. So now at that point, I can now actually integrate something into my actual ASP.NET application. So what I want to do is, essentially, I would like to create a coffee app where I can save my favorite coffee app, my favorite coffee locations. So what I just did is I spun up a little file new Azure mobile app ASP.NET website. So if I go into here, I have some startup code. So as you can see, there's some startup code. I configure an application. It looks and feels like a ASP.NET application with controllers and data objects and models, because it is an ASP.NET application. If I go into NuGet packages here, boom, boom, we can see that I have things like AutoMapper, Entity Framework, the ASP.NET Web APIs, these are all the Azure mobile server components that are here that I've installed. Now what's cool is that I can come over here to this coffee controller. I have a to-do item controller, which is the default. And if I look up top, it's a table controller. It's just kind of a special mobile optimized table controller. So usually you're not just going to upgrade all of your existing controllers to a mobile controller. You usually have a layer on top of it, right? So you have like your main API and then a mobile API. So imagine this is my mobile API. So I have things like get all coffee, get coffee, patch coffee, post coffee, all this stuff, right? It's all there. And in fact, if I go into something like Postman, that's here, I can go ahead and get all my satellites ready, and I like their little thing. I can come in, and here's Get Coffee, Tech Summit Coffee, Azure Websites, get my table. I have this little Zumo token on top, which is essentially telling me that it's a mobile app. I hit Send, and what this should do is it should go off as long as my Azure website is still running, ideally. Come on, Azure website. It's running, it's happy, it's smiling. Come on, Postman. There we go, cool. So now I've actually added, and when I was in different parts, I would go to Intelligentsia, which is very, very expensive coffee, but very good. And so I've added that to the database ahead of time. Now where that's pulling it from is over here in my SQL Object Explorer. So I can go over here and I can go into my SQL Explorer. I'm going to go ahead and remove this database and re-add it. This is what I love, is like I never have to leave Visual Studio. So I go over here and I have the Azure tools installed. So here's my Azure stuff. I'm going to go ahead and find my database. There it is. I'm going to enter my password. There we go. Connect. I'm going to allow this IP address. Let's do it. I think I have a list of like 180 different IP addresses that I add. So now I can just come in here and I have databases. There we go. There's my Tech Summit database. If I drop that down, I can drop down my tables. And what we're going to see is that this API, this RESTful API that you could hit from anything, it could be your website, it could be anything else, is now going to have our coffee table. There it is. I'm going to say view data and hope that it works as it does a round trip to Azure in real time. Bup, 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 bup. If Visual Studio is frozen, you know it's working. There it is. Boom, there's my coffee, right? If I come in here and I'm like, hey, I don't really like this super long name that it gave it. Maybe it's just Intelligentsia. I hit enter. Like all good DBAs would love. I just directly change that data. And I come over here. DBA is going to love that. And boom, it's updated, right? It's in real time, right? It's a real database. That's what I did at our Evolve conference app. I was like, I just do it. Someone's like, change something. I was like, let me connect to the database. Who cares? It's just live. All right, cool. So let's go ahead and actually integrate this to our mobile app. All right, so I come over here into our mobile application. Now, this is beautiful. Now, you remember I was in my ASP.NET application. I actually had an SDK there for the client. I have an SDK here for my mobile application. It's cross-platform. I have a mobile client. I have a SQLite store. It'll actually do online, offline data synchronization and store all your data locally in a local SQLite database automatically for you. It's cool. If you don't want to use SQLite and you want to use something like Core Data, or you want to use something like Realm, or you want to use something else like Couchbase, you can do it too. It doesn't have to be. You can replace anything here. It's really customizable. So let me show you this Azure service here. So inside my shared code, right? So again, shared code, sharing all of my Azure calls. I have this Azure service. And to be able to insert, update, and delete all my information, it's like 60 lines of code. I have a mobile service client, which I can use to get access to my synchronization context, to get access to all my tables, and to do pushes, inserts, and deletes into my Azure to do online, offline sync. This iMobile Service client is essentially a relational table that I have. It's a relational database. So I have a list of coffees here. And then down here, I have this initialization. So that's how I set up my client. So I make sure if it's null, if it's not, if I've already initialized it once, I'm OK. Here, I should probably move this down below, but it's fine. I have my URL. So this is just the website it's going to use. So techsummitcoffee.azurewebsites.net. I create my client by passing it that URL. I say, hey, this is going to be the file of my local database on iOS or Android, and it puts it in secure storage. You can overwrite where it puts it too. I create my local SQLite store. I define my table, so my schema. If I change the schema, it just auto-updates for me automatically. It's the power of SQLite. It's great. I initialize my synchronization, and then I get my table back. So now this table here, I can do things like insert async. I can update async. I can delete update. I can do link queries on it. It's really great. So I created a few little things. The first thing I'll show you is the synchronization. So here I have a sync coffee. And again, you can see, hey, if I'm offline, don't worry about synchronizing my coffee. I'm offline. But if I am online, I'm going to go ahead and push all my changes to the server and then pull down all my new coffees that I have. So the client will push everything, and then the coffee will pull all my latest coffee. I can pass it unique identifiers. So if I want like logic on my backend to do special calls, so I'm like all coffees only for James, then or some ID, I can do that here. So now if I want to get all my coffees from the server, I just say coffee. I initialize, I synchronize, and then I do coffee table, order by name, and give them back to me. I can do any link query here that I want. There, add a coffee. While I initialize, I have my coffee that I create that I'm going to insert into the database by passing it the name, latitude, and longitude. I insert the coffee asynchronously into my local database, right? I'm not making any network calls, just insert it locally. And then what I do is I synchronize the coffee. So if I'm online, awesome. If I'm offline, don't do anything, continue on. But it'll still be local. Next time I connect to the internet, it'll push it up. I'll show you that in real time. It's pretty sweet. All right, cool. That's it. So now what I need to do is inside of my view model here is I wrote a little bit of code to call that Azure. So here I'm just tying in more shared logic. Load coffees. Do that as busy. Get my coffees. Replace the range that's there. Save a coffee. So I would just pass it the name, latitude, and longitude. Add my coffee. Right, back and forth, asynchronously. If something goes wrong, I can pop up dialog boxes and a whole lot more in here. Again, I'm doing all this stuff right here. let's go back into the Android application and go into my main Android XML. I'm going to go into Toolbox. We're going to do something really just quick. So I'm going to go ahead and tap down some more buttons here. There's one button. Here's two buttons. That's great. Let's go into our properties. This button, that's a terrible name for it. So let's go ahead and say this is going to be our load coffee. Let's say load places. And then this one will be save places. Cool. This is most likely button 2, I can only assume. Button 2, button 3, don't let me forget that. Button 2, load, button 2, load, button 2, load, button 2, load. This is how I code in real life. Button 2, load. I switch back over here. And now what I can do is I have these buttons up here. So save button, load button. Button 2, load. All right, so button, load button, dot equals. Find view by ID, button, resource.id, dot button 2. There we go. Let's go ahead and copy paste this puppy. I'll say button 3, which is going to be my save button. All right. Now I want to add some click handlers on here. So I have load button dot click plus equals. And I already created this ahead of time. So load button click and save button dot click plus equals save button click. Now these little click handlers will do a few things. So down below, really simple. One, whenever I tap on one of those items, I actually save it here. So whenever I tap on a marker, I just go ahead and save it out. So if I've tapped on something, then I can save that coffee. So 1 line of code there, 2 lines of code. If I want to load the coffees, I just say load. Again, because the view model is handling all of it, then I respond to it automatically. So let's check this out. Let's just go ahead and spin it up. I've now configured all of Azure, done everything. About 60 lines of Azure code that are shared between iOS and Android. Boom. And now I can go ahead and do this here. Let's go ahead and load this up. And we'll go ahead and redeploy over here onto my application. Building, building, building. Ooh, now my thing's on 3 minutes. Deploy quicker. There we go. Oh, I'm offline. So let's go ahead and go back online. There we go. Probably important. Deploying. You can do it. I have faith. There we go. All right, so there's my coffee app. We're going to go back over here. And the first thing I can do is I'll just do I'll zoom out a little bit. And this thing here, I'll say load places. So it's going to go off, load all my places. So the first time it's going to go and it's going to query, it's going to handle all the database connections for me. Then boom, there's the coffee place right there, Intelligentsia. If I come in now and I say coffee, and I'll search again. Go ahead and put this down. There's some coffee. That's another Intelligentsia. That's a long name. We'll just pick a random, I don't know why I'm going through. I'll just save this place, right? It goes off, it saves it. If I say load again, boom. Right, I got the Intelligentsia, I got the dial-up coffee. If I come in here and I hit send, now I got 2. Check this out. I'll say search again. I'm just going to go offline, because it'll just say magically I've gone offline here. Now I come over here, another dial-up coffee, popular. I'll say this is here. I'll say save. And boom, it saved instantaneous. Watch this, I'll say load. Boom. Like I'm offline, but I'm loading everything locally from my database. Now if I come back in here and I go back online, and we can see that it's not there yet, because there's only 2 in here. I say load again, I'm back online. It's going to take a little bit longer, because it's now doing that synchronization automatically for me on the back end. At least it should. Come on. You could do it. Maybe. Do it. This is my part, and it's like, do it. So I close it, and I just like reopen. And rest assured, if your user shut your application, all that data is still there. Let's try it again. Well, load places. That should sync it, hopefully. Unless I have some weird conflict that's in there. Boom, there we go. Now our coffees are up there. We'll just pretend it all worked magically. Cool. So now we can do that same thing over on iOS, right? So I come into the startup project. I'm just going to go ahead and set this as iPhone Simulator. We're going to go ahead and relaunch it again. Now I've added those load and save boxes over there. So what I did is I just added those same exact button load, button save, and it's calling the same exact code in my shared logic here. So load coffees, or else get my map, get my coordinates that are here. And now what this will do is it'll launch the application again. And this is where things get pretty cool. So as I launch this application and I search for some stuff, I can go ahead and say load locations. Now this will go off, load all my locations, so we can see the spinner still going. There's my locations that came from Android, my backend system. If I come in and search for something else, let's say like burger. There we go, and search. I can come over here. We'll just say whatever this is. Burger King, no. Epic Burger, we'll assume that that's awesome. And we'll come up here, boom. Like it was just that fast, that full round trip to Azure. Awesome. All shared code, right? 100%. This application is sharing like 70% of code. And I have native UIs on both. Granted, they're not pretty. I could do a better job, but they're there. Cool. They're going to kick me out soon. They're going to kick me out soon? Everyone want to stay for 5 more minutes? 5 more minutes? 5 more minutes. Let's do it. Let's talk about Xamarin Forms a little bit. I have all these sessions on all these things that you can really go in depth on. I wanted to really start, and I always like to show the traditional Xamarin approach because you really get full access to everything. Everything I just showed you, all those models, view models, all the Azure stuff applies to Xamarin Forms too. So what we did is we said, listen, we love this approach 100%, but again, not every app needs it. You could actually probably recreate this app in Xamarin Forms because there is a map component. We had that Xamarin Forms on top, so that shared user interface and abstraction. So it's not every single UI control or every single thing like that. It's what's common on the different platforms. So we add things like 40+ pages, layouts, and controls that you can build in XAML, two-way data binding system, navigation API, an animation API that uses the underlying animation systems, a dependency service, and messaging center. We built not only a UI framework for native development, but we added a full MVVM framework built right in. So all your bindings, your commands, all that stuff's built in, value converters, all that jazz. We have pages and layouts like grids and scroll views and relative and stack layouts. We have controls like maps, editors, pickers, labels, images, things that are the same across the different platforms, right? We also have a great ecosystem of not only open source communities, but also companies that are building controls, not only for Xamarin iOS and Android, but also Xamarin Forms. So if you already have subscriptions like Telerik or Syncfusion or Infragistics, you already have all the Xamarin Forms controls that you can add in Xamarin iOS and Android, so your charts, graphs, all that stuff. It's all there. So if I was building a login page, for instance, it would look something like this. I have some XAML over here. I have an iOS, Android, and a Windows device. I have a tabbed page. I like to show tabs. I have a content page here, first child. I have a stack layout, entry where I have a username with binding a username, which is a property like my isBusy in the background. I have a password, which is a password field. I have a button. I have a text color here of white, a background color of green, and then a command. And that login command is a method in my code behind. When clicked, will be executed. Really nice. Then I have another content page for settings. But what we're seeing down here is the native UIs for iOS, Android, and Windows. We get tabs and a UI tab view controller down over here for iOS with the native look and feel, material design and material tabs, and a Windows 10 look and feel over here. Because it is an abstraction of controls, but when Xamarin Forms runs and lays down your XAML, it lays down the native controls. So it's 100% native. Now it is a framework on top of Xamarin, so there's obviously a lot of some overhead there, right? So a little bit of performance implications of startup time of your application, and the fact that you don't get every single control. But if you're building a line of business or conference, anything like that, I build a lot of my apps in Xamarin Forms now when I don't need all those crazy, ridiculous things. So kind of a way of doing that. So again, even though it's an entry, and we've kind of renamed it, you're like, whoa, that XAML looks familiar, but it's not like my WPF XAML. We have all the same features of WPF or Silverlight or UWP, but it's Xamarin Forms controls. So the entry is like a text box or an edit text or a text field. We just kind of mobilize the API that's there. But all your data bindings, your value converters, your string formatting is all the same across the platforms. I was going to show you a demo, but I knew I wouldn't have enough time. Let me talk really quick about end-to-end. Now, once you have your application, whether it's built with Xamarin, traditional, or Xamarin Forms, we have the world's largest device lab called Xamarin Test Cloud that goes off, and it actually can enable you to build user interface automation for iOS and Android applications, all in C#. So you say, tap this button, do this thing, and it runs your application on real devices in our test cloud. We obviously enable you to build it and ship your application off to Test Cloud and make sure everything's building up right in Visual Studio Team Service or TFS if you're on-prem. It's all there ready to go. It's just a definition step. Build Android, build iOS, build Mac, it's all there. Finally, we have HockeyApp, which is a way of not only distributing your application to all my testers. Maybe you want to test my app. I just add your email. Boom, you get my app before I want to go to the App Store. But it also does analytics and crash reporting of your application. It's all available for iOS, Android, with Xamarin, and of course, Windows. Now, we really want to be your full DevOps solutions. We have all these tools available, but we realize that often, when you're building your application, all these different things, there's more to it than that. Things like A/B testing, live updating, remote configuration, backend services, they're all over the place. Even when Donovan gave his session, we have all these different tools. Now, that's really powerful because you have all the tools, and you can pick exactly what you need. And then if you're using Visual Studio Team Services, you have real fine granular control. But what we said is, what if we just took all these services that mobile developers need, that you need something simple, and combine them all together? So what we did is we're building the next generation for mobile application CI and CD, and we call it Visual Studio Mobile Center. It's in preview today. It takes things like continuous integration, testing, deployment, backend services, analytics, and crash reporting, puts them all in one place for you, for all your applications. You go to mobile.azure.com and sign up if you want to give it a try. It's free while it's in preview. So I highly recommend checking that out. If you want to learn more about Xamarin, xamarin.com. You have my email, motz@microsoft.com. If you want to learn about our DevOps/DevOps. What's really cool before I let you guys get out of here is we have free training. It's called Xamarin University. There's great Pluralsight courses. There's great MVA courses, all this stuff. Xamarin University, our pure Xamarin University is live interactive training. I think it's $1,000 a year. So if you have a training budget, I highly recommend it. That's how you can become a Xamarin certified developer. But snap these photos because we have a portion of it is free self-guided training. So you can go from knowing nothing about mobile. You're like, James just blew my mind with Xamarin. Is the best session of Tech Summit, hashtag MS Tech Summit, hashtag best session of my life. That's out there. You can go here and you can take self-guided. All of the classes you take in self-guided, if you sign up for university later, all your credits apply to the certification, which is cool. But check it out. I love it. There's tons of great guest lectures, all that stuff that's there. Xamarin.com/university to learn more if you're taking a few more photos. If you any of this later, literally just email. I'll get back within 24 hours. And with that, I cannot thank you enough for coming to Tech Summit, and thank you guys so much.